We're going to talk about average rate of change versus instantaneous rate of change. So by the time this lesson is over with, you'll be able to compare the two together and differentiate between an interval rate of change and a one spot rate of change. So average rate of change just means slope. Okay, so these are both rates of change. So we're talking for the average slope versus the instantaneous slope. And remember that slope means derivative. So both of these are pretty much asking for derivatives, right? But the average rate of change is asking for the average of all slopes of tangent lines over an interval. Whereas the instantaneous rate of change is asking for one derivative slash slope at a single spot. Okay, so if we just take a look at this picture right here. So the instantaneous rate of change, I would have to say something like this. Find the derivative of the function at x equals 2. So we go here to, and we look at the tangent line, and we would say, okay, the slope is, I don't know, let's just say it's a half, and we're done. Okay? As opposed to the average rate of change, so the average rate of change means I need to find all slopes of tangent lines and then average them out. So I would have to say, and it has to give you an interval, let's say from x being 1 to x being 5. So from 1 all the way over here to 5, so we would think about all these tangent lines, all these different ones, and then average them together. So when you see average rate of change, it is talking about the derivative over an interval. And so what we're going to do is we're just going to do our slope formula using the endpoints. Whereas if it says instantaneous rate of change, we're going to figure out the derivative at that one x value. And you can either do this by hand, using like one of our rules from lesson 3.3, or you can use Math 8 on your calculator. So this one says, what's the average rate of change? Okay, so what we're going to do, we're going to attempt this with a non-calculated method right now. So here's this little function. What's the average rate of change? These are both x values. That's the interval. So they're saying from x being 2 to x being 2.1. Now granted, there could be a ton of ones in between. We want to know the average. Well, what we're going to do, instead of trying to find them all, we're going to get the y values that associate with there. So 2 squared minus 3 is 1. And 2.1 squared minus 3. So remember, 2.1 times 2.1. That's 1, that's 2, that's 2, that's 4. So we get 1, 4, 4. 2 in. So that's going to be 4.41 minus 3. So then that would give me 1.41. And so I don't really care how many are in between here. So what I'm going to do is I'm just going to find the slope, the average slope between these two. So now I'm going to go 1.41 minus 1, 2.1 minus 2. So that will give me then 0.41 over 0.1. And I'm going to move this decimal point over 1, I'm going to move this decimal point over 1, and that's going to give me 4.1 over 1, which is 4.1. So the average of all of them in between 2 and 2.1 would be 4.1. As opposed to an instantaneous rate of change at just that first endpoint 2. So then I'm going to say, well, I can't really do this whole slope formula because the slope formula means that we know 2 coordinates. And if I don't know 2 coordinates, instead of finding the slope normally, I'm going to find the derivative. And so this is just a power rule. That will give me then 2t minus 0, which is just 2t. And now I'm going to find the derivative at the point 2. I'm going to do the same thing now at the point 2.1. And so really what this would be telling me is that, think about this for a second, at 2, the slope is 4. And then at 2.1, the slope is 4.2. So it's a little bit steeper. So it's just pretty much telling me my function would be going upward like this. And we would actually already know that by graphing that ourselves. But this is just giving an idea of what the slope is going to do in the actual picture itself. So remember, the average rate of change, you actually perform the slope formula. Whereas instantaneous rate of change, you actually find the derivative and then plug in a value.